Welcome back to another YouTube Tuesday. My name is Derek, and today we're going to be going over a video that was sent in by one of you guys for us to review. It's brought to you by the channel Joey Does Tech. He uploaded it just over a week ago, and so I think we should take a look at it. Let's get into the video. Before we hit play, if you'll notice, Joey Does Tech is nearly at 100,000 subscribers. So head on over and subscribe to him if you haven't already, so we can push him over the 100,000 subscriber mark.
Shall I put the disc in and see what happens? I've never done this, so I don't know what would happen. What set out to be just a normal day of repairs for this PlayStation 5 console turns into something that I didn't even think would be possible, and I'm pretty sure in the repair community it's quite well known that if you use a digital edition BIOS, you shouldn't be able to read discs on a disc edition PS5. I never usually say this, but if you want to skip the entire repair process of this console, go to around about the 25-minute mark. I'll leave a timestamp in the video, and it will take you pretty much straight to the testing aspect. Enjoy this one, and let me know what you think, as always. Looks like the remove power supply has an X scratched on it. Really? Ooh! Bridger has come in with such a good find. I can't believe I snagged this one. I put in a best offer for it. This PlayStation 5 is a lovely jubbly. No.
So it looks like we've got a few foreshadowings of the end result. Something that provides shock factor and what looked like a discovery of some kind. If you're not familiar with what he does, a lot of what he does is he buys devices that he can find for cheap, and he sees if he can fix them. Sometimes they're easy, sometimes they're hard. So this is probably going to be one of those where, given that it was a recommended video, it's probably more than just a simple fix. Let's see what he runs into, and let's see how he fixes it.
No power, okay? Supposedly, anyway, disc edition faulty no power will not turn on. It was on offer. It was listed for £140 is what this was listed for. I managed to pay £126.65. So I put an offer in of 120 plus postage. It was £6.65. Very good price. Now, I know the question that everybody's waiting for. Does it have a warranty sticker? Okay. This might be new to me. I don't think I've ever worked on a PS5 that had somebody else's warranty sticker on it, by the way. So somebody else has worked on this PS5. Let's firstly just confirm that it's no power. Nothing. Okay, no power. What model is it? Is it a 1216A or what? I don't think it is. I think it's a 11, I think. Is it? Yeah, 1016A. Okay, so it's a 1016A. Which is good because if it is a power supply, I've got these power supplies. I don't have the 1200 model power supplies.
A lot of the time when you have a PlayStation that's completely dead, it is a power supply. It can also be a short. There's a bunch of things that can cause it to have shorts. There are several different lines that can fail. And it's pretty easy to determine if you have a multimeter whether or not you have a dead power supply or not. So that's typically a quick fix, and given the length of this video, I kind of doubt that it's going to be just a power supply if power supply is also dead. So let's see what it does.
Let's have a look and see what the situation is. I'm actually quite excited but nervous about this, if I'm honest with you. Well, all the screws look like they've been put back, and everything looks like it's being put back normally. So whoever did work on this has done a good job of that, which is usually a good sign that they've straight off the bat done quite a good job, in my opinion. That sounds silly, but if you take care of like the screws and putting stuff back, it bodes well for you. Have you tried turning it off and on again? Doesn't look like we have any issues here. There hasn't been UART hasn't been used up here, which is again a nice thing to know. I wonder if this was something as simple as like a HDMI port swap, but it's died for another reason after that, you know, like a lightning strike or something along those lines. How is the LTT screwdriver? I like it. I really, really like it. For small repairs and stuff, it's really good. They need more screws? They do. You're right. Yeah, PS5s do need more screws. I agree. Right, let's have a butchers. I've left one. All right. First things first, shall we check and make sure that we get 12 Vs? I don't think we're going to get 12 volts.
Dead.
We don't have 12 volts. Now, I need to check and make sure and see if it's going to be the power supply or whether it's going to be a 12 volt short on the board. Let's just see. If we put this into continuity mode, do we have... Because the power supply might be shorted as well, so we do need to be cautious here. I'm just going to see if we get 12 volts. No. See that? So for some reason it was coming up as a short, but I genuinely believe what we've got is a busted power supply. And the power supply is shorted, which is what's causing this climb in ohms and resistance. So I think the power supply is bad. I will confirm that. Caps charging. Yeah, exactly. Yeah. I think it's just going to be a busted power supply. Wow, what an easy, good profit. What an easy, good profit here. Oh, it does. Yeah, this is OG board as well, by the way, a 010. So this has the this stuff. What did they replace? Did they replace the HDMI? No, they didn't. Why did they go inside this then? Maybe this is a cheap power supply because somebody's been inside this console before. Let's just have a look. Yeah, look, something's wrong with that. 0.6 volts. I reckon this is like maybe not a cheap power supply, but the power supply they replaced it with has gone bust for whatever reason. Saying that, this hasn't been opened before. Maybe it just had a bit of a clean. And what do I mean? So this part here, let me just lift it off and just confirm. Yeah, that's not been taken off before.
Mm-hmm.
So this is a, or has it? I don't know. Ooh, I don't know. Unless they've just like done it really, really well and like perfected.
Those white stickers tend to break. They come off if you're patient. And so probably it's just something simple like that where you're trying to look for evidence of somebody being inside of it, seeing if they've gotten to the point where they've actually done some diagnostics or some types of repair. I'm sure we're going to find some work done because somebody went through the trouble of putting a sticker on it. We'll see what he finds.
Did it and just done it so like slowly. But this is super clean as well. A little bit of dust, but nothing drastic here. Nothing microfiber can't pick up. Potential damage from a lightning strike or something like that maybe. This power supply looks fine to me. It doesn't look like it's been replaced. So here I have another faulty power supply. And no, just as an FYI, I won't be fixing this. I know there's going to be some people thinking, Joey, why are you noob? Guys, I don't feel comfortable.
I think I caught it, maybe you guys did. That power supply had what looked like a scratched X into it. So I'm assuming that someone's going to pick up on that as well because he did this on a live stream, and a lot of people catch things like that because they're looking for stuff along the way. And what that might indicate is that somebody's gone through and they've, because they were unable to fix this, maybe it had a good power supply and they swapped it out with a known bad one so that they could set that aside for another device for profit in some way. So potentially something shady's going on with the sale, and maybe that's why they accepted it at his first bid and so quickly. So who knows? Let's see.
And this will be such a nice, easy profit by just getting another power supply and replacing it. Looks like the removed power supply has an X scratched on it. Really? Ooh. Bridger has come in with such a good find. There is an X on this power supply. Can you see that? And that has been marked on the power supply. What does that mean? This is what instantly comes to my mind. Somebody wasn't able to fix his PS5 for whatever reason. What they've done is they've replaced the power supply and said that it's a faulty no power and put a bad power supply in to make it look like it's going to be an easy fix for someone like me. The only way we're going to be able to tell and prove this is if we now go to power this console on and we have something like graphical glitches or something along those lines. We've been scammed and we've got the proof here. If that is the case, I may be leaving some bad feedback. Let's see. I won't get ahead of myself. Bridger, as always, attentive as anyone can be, and absolutely smashed that one out of the park. So thank you, mate. No wonder why it was potentially so cheap. The eBay seller had 97% feedback, which is more than average, but not perfect. So why would that be? Let's have a look, shall we? Put the board in. Should we check for shorts quickly? Let me just see if there's anything on the board. I can't necessarily see anything other than a few little marks here and there, but nothing drastic to indicate that this has been gone into before and poked around or had any components replaced, but that doesn't always tell the story, does it? Okay, right, let me just plug this in. I'm just going to put it into continuity mode and check our rails. So that's our 5. That's our 3. So we don't have a short on our 5 or our 3. Let me plug it in, see what happens. All right, will it turn on? I've just had 3 beeps. You know what that is? You know what 3 beeps is when you push in the power supply? I'll tell you this straight off the bat from what I've experienced again. It's the BIOS. I had 3 beeps before I've even gone and attempted to power this on. That's usually the BIOS. Let me check. Wow. Crazy. Crazy. I can't believe it. Has this been changed? Doesn't look like it. This is good. So I message the buyer and just say, hi, this is what's happened. I'll give you the chance to make this right because it's not right morally. Should I do that and see what they say? I'm not really that person, but I also feel like I have been scammed because I put an offer in for 120 and he like instantly accepted. What I'm going to do is put some heat into the board. I go 480 degrees here. I'm just going to put some heat into the board. Then I'm going to apply some flux around the BIOS chip and put some leaded on. And the reason I'm going to do that is because it's going to lower the melting temperature, which will make it easier to get this BIOS off. 9 times out of 10, the BIOS is actually very difficult to get off. And I think the main reason is because this is a massive ground plane here, which obviously this pin is connected to. I could be wrong, but I think that's why it's so sometimes very, very difficult. So I'm just heating the board up. Oh, too much flux. And the reason being is because I had my hot air gun close to the flux.
It's difficult in general just because the thermal mass behind this logic board is quite a bit. It's a thick board. It has a lot of ground plane. It sucks heat away from things. And there's quite a large area of ground plane there. So yeah, that could definitely contribute to it. But it's just a thick board, so you have to apply quite a bit of heat. And with the faulty BIOS, you definitely get that type of response. So it could be the issue, if not one of the issues, besides the power supply.
Tube, so it's got hot. Hopefully we can read what's on here. All right, so we can see all of those melting nicely. Lovely, lovely little job. We can take our reader. What am I doing now? I'm reading the IC. So I'm taking the information off of the IC. Hopefully I'm going to be able to read it. It's picked it up, says successful. If I just quickly scroll down, looks to be okay. Now I need to just put a donor 1 on. Well, this is going to be an exact replica, isn't it? So I shouldn't have any issues because I'm just literally copying and pasting. Take our little chippity chip chip. So this is the one that is supposedly bad. Supposedly. I'm down to 300 degrees, by the way. This one is our donor. Put that there. I don't necessarily want to show this, you know. I can talk about it, but I don't really want to show it. Now, 2 things are going to happen. Either we're going to fix it based on the copy that we've taken from that board, or the copy is going to have an issue. And maybe the chip is okay, but the copy's not, which can be a little bit more difficult, should I say. Right, so that's been done. This is 450 degrees Celsius, airflow is 50. Let's try that again. Pin 1 is top right. This is 450 degrees Celsius with an airflow speed of 50%. Okay. And remember, this is a copy, literally a carbon clone copy of the data that was on here previously. So I come with my microfiber here, a bit of IPA. There we go. Right.
So if the data is corrupted, when you copy it, it's going to be corrupted. Now, if you want to learn more about copying the data, what you need to do that, head on over to his channel. If you watch enough of his videos, you'll figure it out.
Has this fixed it or not? What an awesome little fix it will be if we have managed to fix it. If not, we'll come to that. I've not prepared myself mentally for that yet. So yeah, it could be the data on the chip is corrupt, in which case, you know, worst case scenario, I'll be able to make this into a digital. Best case, I might be able to work some magic with the pairing for the disk drive and whatnot, but we'll see. Plugging in the motherboard. Do we still get the 3 beeps when we put the power cable in? That is the biggest question of them all. Fixed and the joke is on the seller. I hope so. I really hope so. Now hear me out. No 3 beeps. No beep beep beep. No beep beep beep. Which is how I knew exactly that this was going to be a BIOS issue. Didn't get that this time. 3, 2, 1. Okay. Let's check voltages. 12. 5. 3.3. What happens when I go to give this 12 volts from my power supply? I want to see what boot I get, what boot sequence. I still think it's going to be the BIOS. Okay, 12 milliamps. Potential to be a self bridge. Wait. 3.3 fine there. Am I tripping, or did we have 3.3? Did we have 3.3? So where's it gone? 0.2? 0.05? I thought we had 3.3 before. I swear I read out 3.3. I said 5.5, 3.3. I said 12, 5.5, 3.3, which is why I started then testing around the board. Yeah, I think it could be Southbridge as well, you know. Just rewound, you had 3.3. So do we think BIOS is okay? Yeah, the actual BIOS image could be disrupted. Yeah, you're 100% correct. Corrupted, sorry. Let me just check the back of the Southbridge quick. We all know what I'm looking for here. About 7 to 900 ohms. 6K? 7K? 8K? Oh no, there we go, 800. It's because I was in the wrong mode. I was in resistance rather than continuity. My continuity comes up with 800. Yeah, there we go. Okay, so Southbridge, okay. Well, Southbridge might not be okay. We don't know. 700 there. Initial readings look okay to me. Where's my little friend? This little chip, honestly.
So if you don't know what he's doing, he's probing around with his multimeter. And a lot of this comes based off of experience. There's not really schematics and board view software for this type of device. And so you kind of have to know what you're looking for. Once you've tested enough of the circuits, you understand what voltage you should be getting, what continuity readings you should be getting, and where or not you will find shorts, because there are common failures on pretty much all devices, including PlayStation 5. So by testing around with the multimeter, you'll be able to isolate the issue and hopefully fix it. Some things are completely unfixable because they're paired. In a sense, kind of like Apple pairs certain things where you can't get around if you don't have the original. There's a lot of similarities, carryovers as far as those concepts are concerned.
This chip has sent me round roundabouts recently. 400, I think that is low on that rail, as in like it's meant to be that, pretty sure. So wait, okay, so wait a minute, the 3.3 is shorted now. Wait, what? What's that? Oh, it's fluff. Okay, fine. That is shorted though. Look, we have a short on our 3.3. I swear I had 3.3. Did I short something out? I mean, that doesn't look healthy. This is the Wi-Fi I see. I mean, the thing is as well, the reason why I'm a little bit concerned here is because the whole board was pretty clean. I'm just checking the Wi-Fi I see as well, because we get 3.3 on Wi-Fi, don't we? Wi-Fi fine. Okay. And Southbridge okay. So something is short on the board. This is the method that I like to use. I'm going to check the fuses. Most of the fuses I think are 5 volts. There's a couple that are 3.3, maybe 1 or 2. Can't ever remember which ones they are. But I'm going to check, because maybe we've got a blown fuse somewhere. That are okay. That's okay. That's okay. 502 is okay. I will just check as well, because you can have a blown fuse and a short both sides. And then that way you just get a continuous path either way. But I'll just check as well. No. So far so good. 501. Never really seen that blown, to be honest. No, that's okay. Yeah, I had to check 7001, didn't I? Let me check on the back. We've only got a couple. I think there's one this side, isn't there? 002. Yeah. And 002 isn't shorted either side. Here we go. Found it. Found it. Stab in the dark. Right here. Not necessarily that cap. This circuit here on F7003. God knows why it doesn't blow the fuse. I have no idea. Because look. Fine. And no short either side. But if I measure around. Here. This rail. So it's either going to be this cap, or the one on the back. Could I use voltage injection to guess? Absolutely. Am I just going to remove it? Absolutely. It's 1 out of 3. I'm just going to pick one. And we're either going to come off smart or dumb. Could be the IC, yeah.
Given that there's 3 caps, you can simply remove them. And one of the fun techniques that he uses is he'll remove it by not fully removing it, but by just shifting it so that it breaks the connection. What this does is it isolates that part of the line, really isolating that component, because if you slide that component to where one side of it isn't connecting or connected to the connecting the data to the ground plane, and it was the shorted component, you will no longer have a short on that line. If you still have a short, then you can quickly put it back without having to pick it back up from wherever you put it, potentially losing it because it's not the problem capacitor. So I like his technique that he uses for testing these particular types of things.
Short be gone or short stay strong? Short stay strong. Maybe the wind bond IC itself, potentially. I don't see how that could have shorted out the 3.3 though. This one or this one? Could obviously be the chip itself, but this one or this one? I'm going to say this one. The last one you try, probably. Short be gone or short stay strong? Wow. Okay. The last one, of course. unless like we said, the chip. Very possible. Oh, I don't want that connecting to that line. Now, I just want to confirm something. It's not good. It could be internal. It could be internal. Okay. Really hope not. I have to inject voltage now. We took the stupid route and we got a stupid answer. So now we do voltage injection. And we pray something gets hot. We pray something gets hot. I'm going to start with, it's a 3.3 volt rail, but it could be shorted, to something. I think it is just ground, but you can never really risk it. So I'm going to go with 0.7. I'm going to go with 0.7.
So he's going with 0.7. That's a fairly low amount. You really want to avoid injecting voltage into a shorted rail if you can troubleshoot it without doing it. Otherwise, you're just putting power into a short. If causing potential further damage to the component or the lines or the components in that line. One nice thing though is a lot of the time when you inject voltage with a thermal camera, you can actually isolate the shorted out component. That doesn't necessarily mean that the component that gets hot is the bad component. Most of the time it is, especially if it's a capacitor. If a capacitor lights up, it's in almost, I don't think I've ever seen a case where the capacitor lighting up wasn't the culprit. But if a chip lights up, that doesn't necessarily mean that the chip is bad. It means that something downstream of that chip could also be the culprit. And so having the values of the pads that the chip is soldered to definitely helps isolate the issue. Sometimes it is the chip itself. Sometimes it's the chips that they can go bad. But just because something gets hot doesn't mean that it is the issue. A good portion of the time it is, but doesn't mean it's always the issue. It's just something to keep in mind. I have a feeling that it's going to be the south bridge based on where he's testing in my experience.
Just see what we get. Dead on an amp. Dead on. And the board is hot, so it's going to be really hard for me to actually see where this is coming from, unfortunately. Let me move over a bit. South bridge. Can you see that? You see this little heat spot just here? South bridge. Okay. Even though we didn't have a short on the back of the south bridge, we've got a shorted internal south bridge. So things can look good on the surface, but deep down, not good. Just for my own sake here, and just for my own knowledge, I'm quickly going to see if there are any caps on the back of the south bridge that are shorted. Just quickly. Ah, look at that. So here we have an ohm. Here we have 2 ohms. The first cap that I test, so I kind of skirted around the outside. So my measuring pattern for the south bridge is like, I kind of start here and then I go to the right on these inductors, up here to these inductors and this cap. And you can see right here in the center, we have a 2 ohm short on the south bridge. I have to ask myself a question though. What's blown the south bridge? I never seen a BIOS blow a south bridge, and that BIOS, I mean, it was taken from a board. PSU maybe? No, the PSU wouldn't have blown it. PSU with an X. Oh, yeah, maybe. No, because I had the 3.3. You know what? South bridge is reading the BIOS data to start the board. You can have a good BIOS and bad south bridge that is giving you trouble. So you think maybe just a bad south bridge. It's weird though, RVNR, how I had the 3.3, no? If I didn't have the 3.3 to start with, I would have been more inclined to be like, yeah, 100%. This is a 61 GG. Please tell me I got 61 GG. Yo! We got 61. Make sure I've got my wick. 480 degrees Celsius, 99% airflow. Kindly check the orientation of the BIOS. It's fine. Pin 1, bottom right. And you can see that's where the arrow. See the arrow? Pointing to pin 1. Pin 1. Come with our flux at the side there.
So a couple tips and tricks for soldering components like this. One thing to keep in mind is whenever flux is hot, it's really easy to work with. It's easy to clean. It's easy to remove. As soon as it cools down, most flux becomes harder to remove, tacky, and things are much easier to do like wick pads while things are still warm. So one thing that I like to do if I'm ever having to replace the south bridge is once I pull it, normally I have wick ready, but I normally go to wicking it. Otherwise, I'm going to be spending the time to add like a lower melting solder, mixing it with the factory solder, and then wicking all of that up. And if it's still warm, I don't have to worry about adding low melt because I can quickly wick it because it's hot. Because you have to get this board really hot like he did with the BIOS to remove the south bridge. And while it's still hot after you've wicked it, you can quickly wipe it away with a cloth and then you can clean it up with some isopropyl alcohol or a board cleaner to apply new flux and a new south bridge that's pre-balled or that you reball in order to have a clean installation. So let's see what his techniques are.
We're going to be very quick here as well.
He's added some low melt.
That has been put in place. Now we come in with the wick. We're going to act quick with the wick. Quick with the wick. And why am I saying quick? The reason being, guys, is because if you don't act quick, things get cool. And when things get cool, especially solder, it takes a longer time to get it off the board. And that's where you can look to rip pads and take off the solder mask, etc., etc. If you do it when the board's hot, there's a lot less room for mistakes. In my experience anyway.
The solder mask is the green top coat that he's talking about there. And the braided wire, the wick, kind of can act like sandpaper, especially if you're working on a cold surface where it'll literally just braid away the green coating, exposing traces and places that the solder can jump to, creating potential shorts and issues. So I like how he's going about showing this. It shows that he does this often, and it's a really good tip and trick to how to be able to do really bigger chips like this. So
here we go. Microfiber, where you at? IPA, little clean. What's sticking to me? Oh, that's another Southbridge sticking to my hands. Is that one I've just taken off? Probably. And if we act quick enough, the board's still going to be relatively hot just through it. It's got a good amount of temperature on it. So if I come in here with my flux.
You saw how thin he took a Q-tip and he really thinned out that flux. Flux really acts as a shield. It prevents things from oxidizing. And there's more than likely the chip that he is installing is reballed and has flux already kind of surrounding the solder balls, but you want to also have the pads protected by that shield of flux. And so that's why he smeared it thin. That also causes the chip not to want to float around, because this chip, the pads are so close together and the solder balls are typically larger, and you really don't want them to bridge together. So you don't want a whole lot of movement when soldering this chip down. And so to begin with, until it starts to stick, you really don't want that much flux. You want enough flux to not oxidize things, but you want to add flux once you know that it's stuck to really make sure that everything flows properly and is making good, solid continuity for the function of the circuit.
Lift it up. 450 degrees Celsius here. We can still go in with a high airflow speed. I'm gonna go 80%, and I'm not gonna poke it. I refuse to do the poke test now. I learned from my mistakes. Hopefully, watch this float into place any second. There we go. See it just slowly shift into place. That's what we want. Come off the heat. Inject our flux. Come back in. And now we'll just go back in for the reflow. It's going to be hard to know if we've got the reflow or not when we don't do the nudge test, but we have to go by feeling. Just a bit of experience, I guess. Like now. I reckon that's reflowed. Okay, off the heat. Wait for it to dry for a sec. Right, I need to flush this out, guys, because it's going to be cool enough now. And what do I mean by flush it out? I put a bunch of IPA underneath. I get a can of air, and I flush it. I just rinse and repeat that a couple of times. Let's check the corners of the chip. We're going to have 4 sides here. That looks good. Ball's nicely aligned. Doesn't look like there's any of them together, which is nice. Next side. Good as well. This side.
That looks good. All flux has the ability to corrode, even now clean flux has the ability to corrode things over time. So as much flux as you can remove, you should remove. And his technique to kind of take some compressed air with some isopropyl alcohol and spray it under, that's a good one to keep in your back pocket.
Squish down there. I think that's a little bit of flux. I don't think that's going to be a bridge from what I can tell. I think that's okay. Just a little bit of flux under there. But again, looks okay. Let's check for a short. That'll be our first thing. Should have probably checked for the short before I put the Southbridge back on. But so do we have a short? Nope. 900 ohms. That's all good. 900. This inductor, 900. Let me check. I need to put that inductor back, don't I? Because I took it off. Just flow these back into place because they look a little bit out of line, don't they? I don't want the flux going everywhere. That's why I got it on such a low speed at the moment. There we go, it's better. Do we replace the BIOS chip again? Check boot sequence. That's a very good point. Do we agree with that with G-Man? If we check the boot sequence, that's not going to give, hopefully, it won't give it enough power to actually short out because it won't attempt to turn on. Should we check the boot sequence first? Okay, so boot sequence and then try a digital BIOS. 3, 2, 1.
Nice.
Did you guys hear that? Please tell me I've still got 3.3 volts. Yeah. Okay, sweet. All right, good. We don't have a short in the same place we did before. So replace the BIOS with a digital BIOS because we feel as if though the BIOS data is what's corrupted, not the BIOS chip. I can use the same chip, but I'll just put a digital BIOS on it. All right, 12 Vs. Please don't break the Southbridge. So with a 010 BIOS disk edition, we get nothing. I get 9 milliamps. I'm so confused. I am going to try a 010 digital. Here we go. Let's see what happens. Ready? 12 Vs. 3, 2, 1. Well, it works. Works with the 010 digital. Doesn't work with the 010 disc. Should I try a different 010 disc? Right, here we go. Moment of truth. 3, 2, 1. Yes.
Shut off.
I don't believe it. Like, what else? What do we get? I've got one. I don't know what one it is. Oh, okay. Guys, you won't believe what it says. You won't believe what it says.
HDMI.
It's the HDMI IC. Or it's a power failure. But it's a pretty good indication. It's pointing us exactly where we need to go. Where I need to look for.
By the way, if you notice here, the error code here says it's an HDMI problem or power failure added by the coder with a 3. If you guys haven't watched his videos, this is what he does. He repairs consoles and other things, but mainly consoles. So he really knows his stuff. But there's a really good chance that this is going to be an HDMI IC issue. More than likely, someone's tried to replace it before, and they either did it improperly or they overheated the chip. It's hard to say exactly, but I'm sure he'll be able to determine whether or not someone's worked on it before or not.
First, anyway. This PS5 is pulling my pants down. It now wants me to have a look around the HDMI IC. If I go ahead and inspect the HDMI IC, find something wrong with it, replace it, and fix that element, and something else happens, I don't know what I'm going to do. Wait! Oh! Oh my gosh.
You can tell just looking at it that somebody has grabbed it. You can see all of these marks, tweezer marks on the side, and what looks to be the lack of solder. You can see, for example, these first 4 pins have, I should say pads, these first 4 pads have solder on them, and then it kind of looks sparse with a couple here and there that have solder on them. So there's a really good chance that this chip just doesn't have the proper amount of solder, and it also looks like it's off a little. One thing you can notice is these little squares in the corner of the chip. They aren't perfectly aligned with the corner of the chip. I mean, it's a slight amount, but enough that it would bug me. If I was replacing this chip, I would want to nudge this slightly, a little bit, twist it just a little bit so that everything lines up on all sides. And I would be going in and making sure that each one of these pads had as much solder as these ones do down here. As you can see, these ones look sparse. These ones, good portion of the side ones, almost all of this side just doesn't have any. So it could be that this chip is totally fine. It's not every line is actually making good connections. So given the damage to the chip, I'd probably be replacing it though, because someone has definitely kind of scratched it with the tweezers pretty heavily.
I don't believe it. Guys, that's been replaced. Looks burnt. I wouldn't say it looks necessarily burnt. I can't believe it. That's just where they've like held the tweezers, you can see. Can't believe I didn't spot this. Thing is, it hasn't had any flux around it. Do you know what? Fair play to them again. This screams to me that they've obviously, but they didn't use UART actually. They didn't use UART because the UART connections where the solder goes were new. So they hadn't put anything to UART, but they were right in the sense that the HDMI encoder was faulty. Just got even more interesting. Do we have any shorts around it? If we do, I'll be so happy. No shorts. Hanging on.
You can see how off it is. Each one of those is kind of, like you said, hanging on for dear life. But one of those things that I like to see is, for example, if you look here at this one that I've got my cursor on, it's kind of like a copper color. I like to see the solder jump up to it. That way I know that it's solid. And although you don't necessarily need it to jump up, it's my kind of indicator that it's got plenty of solder and enough solder and it's going to make connection no matter what. So seeing that kind of worries me a little bit. Let's see when he rotates it around. If he does, let's see if there are any that look like that as well.
I mean, you could argue that maybe those points are like soldered at the bottom. You could argue that. Let me check the other sides. I mean, again, you could argue that it has been soldered. Oh, it looks like very dry solder there. Oh, maybe those ones aren't connecting there. Yeah.
Yeah, like you can see a lot of these don't even look like they're connecting. There's this good, nice little, almost like a shadow of a line where the chip meets the pad. instead of a nice bridge of solder jumping up onto the side of the chip. So this was improperly soldered on. Maybe there's too much solder under it that didn't melt on the big ground plane that's below. Like they didn't compress it down onto the board, or they didn't apply any solder to the pads before applying it, or tinned the chip at all. There's a bunch of things you can do to make this easier on yourself. So at this point, I would just replace this chip.
Yeah, maybe that's a side that we seemingly have an issue with. G-Man says, yeah, it makes a very, very good point. Maybe it had no display and they replaced HDMI encoder and now they have a power issue. I'm going to get this off the board with 480 degrees Celsius and 99% airflow. Get a nice grab on the chip. You're coming with me. Now quickly, because I don't necessarily trust, or I should say probably shouldn't trust the previous tech that worked on this. Only because you should always trust your own work. So I'm just using soldering iron here to go over the pads and just make sure we've got enough solder on the board. And hopefully we should be able to just now float this in place. Is the goal. Microfiber. Toothbrush. Right, let's just inspect this chip and see.
So now looking at his installation, the corners line up perfectly with the little gold squares. He compressed it with the tweezers. He added plenty of solder and flux before, and you can clearly see all the way around that the pads aren't sparse of solder. They each have plenty of solder that look, at least from this angle, like they're jumping up onto the side of the chip. So this is something that he probably doesn't have to touch up at all with a chisel blade. Iron tip going around the border is probably good to go. I really like how he showed that, and that he hasn't scratched the chip. So
see how we're getting on. They look like nice connections to me. This side, a big oof, a little bit lopsided. I just want to make sure that the connections are all good. If not, I'll have to redo it quick and just tap it upwards a little bit. I mean, they all look soldered to me. Hold on, all good as well. And this side, yeah, I mean, they all look soldered to me. Yeah, they're all soldered.
So it looks like the chip could have been slid up just a hair, but that being said, there was plenty of solder even going at a slight angle to make it. So there's no point in overheating if it's making good connection and it's that close. Let's see what his result is.
Soldered. Okay, I'm not going to do anything with it. Are we ready? 3, 2, 1. Stay on. Stay on. Stay on. White light, please. Please, white light. But I'd never seen it do that. I mean, it just doesn't make sense. Time to call the Exorcist. I think so. It's time for UART again. We're getting nothing. I'm getting zilch. I'm getting zeros. I thought UART would tell me something, but it also definitely makes sense in the way that the power button is unresponsive after the second press. I don't know why it's attempting to turn on. I have no idea. Why is it doing this? I've never seen this before. There was definitely something going on with the HDMI retimer because this is further than what we got before. Let me see if I can boot in safe mode. I don't think I'm going to be able to. Wait a minute. That was safe. Oh, okay. Safe mode. Hold on. Reinstallation maybe because of the BIOS? Do I get a display? Yes, I do. I get a display! Unfortunate for you, I'm going to have to put it on my ugly face whilst I have a look at this and tell you how it's going. Oh, wait a minute. No, wait. I might be able to show you via... because it doesn't use HDCP, right? Oh, disc! Yo! I take it! Nothing's coming up on the game capture, though, which is slightly annoying because I wanted to obviously show you guys the process. For some reason, I need to disable HDCP then. We're going to reset PS5, install the PS5 system software. Okay. It says can't reset your console. Your PS5 will restart in 20 seconds. Let me plug in my Ethernet cable because I will try and do an update via internet and see if that does anything. 10 seconds left apparently. And then it's going to have to go through applying the update. 1 second left. It's stuck on 1 second. And now it says connect a USB drive that contains the latest system software update file for reinstallation for PS5. Then in safe mode, select reset PS5. Why? So it's asking me to download the latest update from online, but not over Ethernet. Okay. All right. If that's what I need to do, that's what I need to do. Is it going to apply the update, or is it going to fall over at copying the update file? The update file. Connect a USB drive that contains the latest system software update file. And I'm going to try and rebuild the database quick. Put the original BIOS back on. I'm scared to do that because we had an issue with it in the first place and it was beeping 3 times. Right, clear cache and rebuild database. I'm going to go rebuild database now, okay? But I'm doing rebuild database now. Now, this is going to be super interesting because when you rebuild the database, what it should do is it should restart and boot into dashboard. Now, it's gone to a white light. I feel like what I'm about to be greeted with here is going to be BIOS. Yeah, BIOS. So I've tried rebuilding the database. That's not worked. I've tried updating both with the recent update file and also a reinstallation file. I can't believe after all this, we're putting the original BIOS back, you know. I see what you guys are saying, but oh yeah, for sure worth a go. Okay, let's do that. Well, we have been on an absolute roller coaster with this one, hey? Installed back on the board. So to confirm, this is original BIOS new chip, which didn't work before, by the way. I knew it!
BIOS.
The data on the original BIOS is corrupt. That's why. I'm afraid I've obviously tried to do a disk version. That's not worked. I'm now going to do a digital BIOS, guys. Do we agree? Digital BIOS now. And what I will say is that if it goes to a digital BIOS, that's how I will be selling it, is a digital BIOS. I'm not messing around with the disk drive anymore. I'll leave the disk drive in here just in case somebody is able to fix it. But I think that's what we do. If it works with a digital BIOS, we'll leave it there. This poor BIOS.
If you're confused at this point, he's putting on the BIOS that's for a digital version, not for the disk version. Given the foreshadowing at the beginning of the video, I wonder if there's going to be something special here. But this should just basically make this PS5 not able to have the disk drive work. But I'm really curious. Let's see what he says.
Chip has been through a lot. 1. Please go to a white light. Okay. I think we're good. I think it's booted. It's not! I don't believe it! This is a digital. I can't believe it. I'm not going to talk to you again because that was really weird, but